Hi, this is John Maudlin, Senior Systems Engineer for Profitap in North America. What I'm doing today is I'm analyzing Starlink network. I did this a few months ago, and I'm checking it again to see if latency has improved since the last time I did it. Last time I did it, I analyzed some general traffic, and I also took a look at a Zoom call to see how did that Zoom call go. So I'm going to try to do a similar thing in this video. Here I have an IOTA, which is a Profitap visibility analysis capture sensor that has built-in graphics for traffic analysis and the ability to export and download those PCAP files and filter on them and stuff. So here I have one that's on the LAN side of the firewall, and here I have one that's on the WAN side of the firewall. Now, I could have put them in span mode and connected the LAN and WAN to one device, but I had two devices, so I just thought I'd do it this way. So the Zoom call was this morning. It was around 8:30. So let's go back 3 hours here. Let's go back to about 8. First of all, let's pick the Zoom call. So I'm going to go to Application Overview, and I'm going to go down here to look at my categories of traffic here. It's doing layer 7 fingerprinting here for me. I'm going to pick conference, and there you can see there's Zoom traffic. My Zoom call was around 7:30 to around here. There is my Zoom call right there. I'm going to zoom in on it. And now I have a nice Zoom call on my screen. You can see I have 18 flows amounting to 184 megabytes of traffic. It's telling me here that my latency on the Zoom for this period of time was 80.6 milliseconds. It's a little higher than I had the last time, but I've only got 29 milliseconds here on GoToMeeting and 59 over here on Slack. Let's open up this latency and take a look at it down here. Showing pretty high over here on the average, but if I resort it, I can see I've got some pretty nice low winds in there, and I've also got some kind of high winds in there. So it's a mix of latencies, and my traffic looks like it's staying here in North America. When I look at my average bandwidth per client, I can see I'm pulling around 2 megabits per second, 1.5 megabits per second of traffic to support the Zoom call, and that's about typical, and 170 megabytes transferred in that period of time. So let's go take a look at the WAN side of this. Once again, I'm going to look at conference traffic here. That's how easy that is. And I'm going to pick my 8:30 time frame from when I knew I had the call. Zoom in on it a little bit here. Same thing, 184 megabytes of traffic, 18 different flows to support the traffic. I'm still looking at about the same average latencies there on that traffic. And looks like North American traffic, and again about the same megabits per second rate of traffic that I got on the LAN side. So it doesn't look like my firewall is causing any issues. It's the same on both sides. But what I'm wondering, is this a Zoom issue this morning, or is this Starlink? What is this? So let's go back to the LAN side of the traffic, get rid of the application tag. So we're looking at all traffic instead of just conference traffic, say in the last 3 hours. And let's look generally at what we're getting here across the board. Looking at Office, we're getting 54 milliseconds of latency. Teams is 48, Slack is 59, Zoom is the highest at 66. Netflix is 51, Adobe 55, OS updates 58, iTunes 42, browser traffic for DuckDuckGo search engine is 44. So it looks like a lot of my traffic is in the 50s and some in the 40s for milliseconds, which is better than I got last time. Last time I was 60s, 70s. And I think now it's a little, Zoom seems to be a little higher. So it could be that this is a Zoom issue. And you can see my traffic now, looking at all the traffic in the last 3 hours, not just conference calls, is all over the world at different rates per second. And I'm going to go down to my overview dashboard here for all of the traffic. And something else I can do is when I'm looking at the Zoom traffic, I can actually go in and take a look at specific flows of traffic to see on a specific flow how did that traffic go here. So now we've got the filter in place. I'm going to go to the overview dashboard. I'm going to come down here and look for the payroll bytes. The payload bytes. Here I've got 153 meg UDP because all our latencies are calculated on the TCP connections, but the actual video is UDP. And so I can see 153 meg of that. It lasted 17.2 minutes. And if I want to inspect that traffic, I can see my average server bandwidth, and client server and server client, and down here I can see the inbound and outbound or upload and download traffic here and how it flowed throughout the call. We had one burst here in the middle of almost 3 megabits per second. And the call itself went actually good. There was no problems in the call. I just wanted to check it using the IOTA and see what is it actually looking like here. So I could go look at all 28 independent flows like this and check each flow to see, was there a particular Zoom server that was having a problem, or a couple of different Zoom servers that were having a problem, or maybe that's just the way Zoom is this morning. At 20 milliseconds of additional latency, the way TCP/IP works, it just handles it through congestion techniques and delay techniques and buffering techniques. It's built into TCP/IP anyway. So I would say overall, it looks a little better for me. If I go to 1 hour time frame, and I've got 40s for latency in here. There's a couple of 60s for specific applications. But generally, I can see 40s, 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 50, 40s, 40s. Generally, all this stuff looks better in here, lower than what it was. And that's looking on the LAN side. If I do the same thing on the WAN side, get rid of my conference filter, looking at the last 3 hours, so I'm kind of comparing apples to apples here. I can see 40s, 50s, there's a 60, it's a Zoom. And, but the rest of them, except for a few, probably application-specific issues. If you can get a low latency on a particular cloud application, but you're not getting that same latency on a different cloud application, then it's probably not your local network, it's probably the cloud application. But it could be how it's working on your computer communicating to that application. It could be a software issue, but like sort of Windows conditions or something like that. Also, connect. In the initial connection, you have a three-way handshake, and that three-way handshake has some TCP options, and then those TCP options are your TCP handshake parameters, like is your window scaling turned on the client side, is it on the server side, What is the value? Is it 1? Is it 0? Is it 8? Do you have selective acknowledgements turned on? Is there window scaling used? Is the timestamp being used? There's all kinds of parameters in there. And you can check those parameters in the IOTA actually to see, how is that working under your TCP analysis dashboard. You can see the three-way handshakes right here and all of your connections on your layer 3 addresses here. And then you can see the client-side options, server-side options, window scaling, selective acknowledgements, timestamp, MSSIs on both sides, which is really helpful information when you're analyzing slowness to a particular device. And thank you for watching.